Simulan mong abutin ang iyong pangarap na magbibigay dangal sa iyong bukas. Ang suliranin, hindi laging nandyan, dapat mong harapin. Kami iyong kasama sa bawat takin, magkaakbay nating lulutasin. Dito sa Fernandino Teens TV, ang boses mo ay mahalaga. Dito sa Fernandino Teens TV, ikaw lagi ang bida. Ang mga aral ay ginintuang atin ng bawat guro na siyang gagabay sa iyong pagkamulat. Naway umukit ito sa iyong isipan, maging mapanuri, sundin ng wasto at nararapat. Kagandahang asal ang ipakita, ipadama ang pusong may malasakit. Dito sa Fernandino Teens TV, ang boses mo ay mahalaga. Dito sa Fernandino Teens TV, ikaw lagi ang bida. Sakali mang tayo'y subukin ng unos, ating haharapin ng walang takot. Sasamahan ka ni Fernan at Dino, ang bagong barkada mo. Dito sa Fernandino Teens TV, boses mo ay mahalaga. Dito sa Fernandino Teens TV, edukasyon mo'y sigurado na. Dito sa Fernandino Teens TV, boses mo ay mahalaga. Dito sa Fernandino Teens TV, edukasyon mo'y sigurado na.
Fernandino Teens TV.
Uy guys, patulong naman ako dito sa activity ko sa math.
Ano bang lesson yun, Nan?
Factoring ng topic namin.
Patingin nga. Special factors ang mga iyan.
Oo, yun nga. Hindi ko alam sagutin.
Alam ko na. Para siguradong tama ang mga sagot mo riyan, panoorin natin ang episode ngayong araw.
Mabuti pa nga. Tara!
Let's watch and learn!
I have made the most important discovery of my career, the most important discovery of my life. It is only in the mysterious equation of love that any logic or reason can be found, that the greatest equation in life is love. Excerpt from a 2001 historical drama film about a mathematical genius in the life of Professor John Nash. Good morning and hello, Fernandino Teens. I am your teacher, Armido Galibo. Just call me Sir Dong. And I am your mathematics lecturer for today. But before we finally begin with today's discussion, let me introduce to you our lesson objectives. First, to recall the different types of special product. Second, to enumerate the different types of factoring. Third, to factor polynomials completely. And fourth, to apply the different techniques in factoring products. As we all know that special products of polynomials follow a certain pattern that could be easily determined without the use of traditional multiplication. Let us try to recall the types of special product. Type 1. Product of a monomial by a binomial. Type 2. Product of two binomials with similar terms. Type 3, square binomial. Type 4, cube of a binomial. And type 5, product of the sum and difference of two same terms. Are you familiar with these types of special products? Do you still remember this illustration or formulas? Yes, these are the types of special product. Let us recall each type. Type 1, the product of a monomial by a binomial or by a polynomial. In this illustration, the distributive property of multiplication is being used. Let's have this example. 2, the quantity x plus y is equal to 2x plus 2y. Another, 3, the quantity x minus y plus 3 equals to 3x minus 3y plus 9. Very easy, am I right? Let us proceed to type number 2, the product of two binomials with similar terms. The easiest way of finding a product of two binomials is by the use of FOIL method. Do you still remember the FOIL method? What does FOIL stands for? Correct, very good. FOIL stands for the first, the outer, the inner, and the last terms. In our given example, the quantity x plus 3, x minus 2, the first term is the product of the first term of two binomials, which is x times x equal to x squared. The outer is the product of the first term and the second term. In our given example, the quantity x plus 3 times the quantity x minus 2, first is the product of the first term of two binomial, which is x times x equals to x squared. Outer is the product of the first term and the second term, x times negative 2 equals to negative 2x. Inner is the product of the second term of the first binomial and the term of the other binomial, which is positive 3 times x equals to 3x, while the last term is the product of both the last term of the given two binomials. Positive 3 times negative 2 will give you negative 6. Combining like terms, x squared minus 2x plus 3x minus 6, we have x squared plus x minus 6. Let us proceed to type number 3, the square binomial. The rule says the square of the first term plus or minus twice the product of the first and the second term, plus the square of the last term. Given an example, the quantity x plus y squared is equal to the square of the first term, which is plus twice the product of the first and the second is 2xy, plus the square of the last term y, which is y squared. Also, the quantity x minus y squared is equal to the square of the first term, which is minus twice the product of the first and the second, which is 2xy, plus the square of the last term y, which is y squared. Now, let's have type 4, the cube of a binomial. In this case, the following steps must be followed. Example, given the quantity x plus y cubed, the first term x equals to x cubed, plus or minus thrice the product of the square of the first term x and the second term y equal to 3x squared y, plus thrice the product of the first term x and square the second term y equals to 3xy squared. Then, plus the cube of the second term y equals to x cubed. This follows x cubed plus or minus 3x squared y plus 3x squared plus y cubed. Take note that the sum of the product of the second term depends whether it is the sum or difference of the given cube binomial. When the given cube binomial is a difference, then the sign of the second term of the product is negative. On the other hand, when the given cube binomial is the sum, the sign of the second term of the product is positive. Can you follow? Very good. For type 5, the product of the sum and difference of two same terms equal to the difference of their squares. It means that if you encounter two binomials, one is sum and the other is difference having two same terms with the same first and second terms, then their product is the difference of their squares. Example, the quantity x plus y times the quantity x minus y is equal to their difference, x squared minus y squared. Again, these are the types of special product. Dear students, learning mathematics is a matter of practice and patience. Just join me in this presentation as we explore, experience, and discover the beauty of mathematics. So stay tuned and don't go away. Fernandino Teens will return.
Ang Schools Division Office City of San Fernando, Pampanga ay kaisa ng Department of Education sa pagsasagawa ng mga proyekto at programa na tumutugon sa mga pangangailangan ng mga mag-aaral. Inilunsad ang Division Call Center for Tutors and Guidance Counselors upang magbigay ng educational at psychological assistance sa mga mag-aaral, magulang at stakeholders ng division. Kaya, kung may nais kayong itanong tungkol sa pag-aaral, maaaring magpadala ng mensahe sa Division Call Center for Tutors and Guidance Counselors Facebook page o tumawag sa mga numero na makikita sa ibaba ng inyong screen tuwing Lunes hanggang Biyernes sa ganap na alas 8 ng umaga hanggang alas 6 ng gabi. Maaari rin kayong sumangguni sa ating guidance counselors na nagbibigay ng guidance and counseling services. Lahat ng inyong ibabahagi ay mananatiling confidential. Ang nasabing programa ay nagsisilbing daan upang malaman ang feedbacks ng stakeholders para matulungan ang ating divisyon na mapagbuti pa ang mga sumusunod na programa. Ano pang hinihintay ninyo? Tumawag na sa aming mga numero o bumisita na sa aming Facebook page at magpadala ng inyong mga katanungan.
Fernandino Teens TV.
Welcome back to Fernandino Teens TV. I do hope that you will stay with me for the whole duration of my discussion. We already discussed the different types of special product, but this time, I have to present to you the main topic of our discussion. From special product to the inverse process of special product. But before I have to discuss this topic, can you guess or identify the inverse of the special product? May I hear from you? Yes, it is the factoring. That factoring is the inverse process of special product. Let me now introduce to you the different types of factoring. We have type 1, highest common monomial factor. Type 2, difference of two squares. Type 3, perfect square trinomials. Type 4, sum and difference of two cubes. And type 5, trinomials with distinct factors. When do we say that the given polynomial with integral coefficient is factored into a prime factor? A polynomial with integral coefficient is factored if it is expressed as a product of two or more irreducible polynomials of the same type. But when it is considered to be irreducible polynomial, a polynomial is irreducible or prime if it cannot be expressed as a product of two polynomials of lower degree, and if the coefficients have no common factor. Let us now clarify this irreducible factor by introducing to you the different types of factoring. Take note that the different letters used in this factoring may represent any quantity. Are you ready to start? Let's have type number 1. From product of a monomial to the highest common monomial factor. This can be done by finding the greatest common monomial factor and divide its term by the said common factor. Let me illustrate type number 1. Given ax plus ay plus az, find the factor. The common factor is a times the quantity ax divided by a is x plus ay divided by a is y plus az divided by a is z. So the factor of ax plus ay plus az equals a, the quantity x plus y plus z. Let us now answer the example for this type of factoring, the highest common monomial factor. Factor its polynomial completely. Number 1, 3x plus 3y. Number 2, 6ax plus 3bx minus 9cx. Number 3, 4, the quantity x minus 2 plus a, the quantity x minus 2. Number 4, 6y to the 4th minus 30y cubed plus 45y squared. I will show to you the solution on how to factor the first 3 problems. The remaining number 4 will serve as the activity that you have to answer by yourself using a sheet of paper or write down your final answer on the comment box below. We will check them to see if the given correct answer at the end of the entire discussion. Are you ready? Let us start solving. Let us have the problem number 1. Given the equation 3x plus 3y, the common monomial factor is 3, the quantity. 3x divided by 3 will give you x plus 3y divided by 3 will give you y. So the factor of 3x plus 3y is equal to 3, the quantity x plus y. Problem number 2. Given the equation 6ax plus 3bx minus 9cx. As you can see, the numerical coefficients are 6, 3, and 9. And the greatest common factor is 3. As far as the literal coefficient ax, bx, and cx, the common factor is x. So the common factor of the 3 terms is 3x. The quantity 6ax divided by 3x, we cancel 6 and 3, that will give you 2. Cancel x, that will give you 1. So we have 2a plus, again, 3bx divided by 3x, we cancel 3, we cancel x, so the remaining is b. So we have plus b minus 9cx divided by 3x, 9 divided by 3 will give you 3, and x over x will be cancelled, so the remaining is 3c. So the factor of 6ax plus 3bx minus 9cx is 3x, the quantity 2a plus b minus 3c. Problem number 3. Given the equation 4, the quantity x minus 2 plus a, the quantity x minus 2. The common factor is x minus 2, and that is the binomial factor. So we solve for the quantity x minus 2 all over x minus 2. We cancel x minus 2, so we have 4. Then plus, again, a, the quantity x minus 2 all over x minus 2. Once again, we cancel x minus 2. The remaining is a. So given our equation for the quantity x minus 2 plus a, the quantity x minus 2, the factors are x minus 2 and 4 plus a. How do you find the solutions? Are they interesting? Very good. As I've said, you will be the one to answer problem number 4. 6y raised to the 4th power minus 30y cubed plus 45y squared. Let us continue. Type 2. From the special product, the sum and difference of two same terms to difference of two squares. X squared minus y squared equals to the product of the quantity x plus y times the quantity x minus y. In this type, we are recognizing a certain pattern which is the sum and difference, considering that the given terms are perfect squares for both the numerical and the power of the literal coefficients of the given term. A numerical or a number is a perfect square if it is expressed as a product of two equal integers. Meaning, you must be familiar with the perfect squares numbers such as 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is equal 16, 5 times 5 is equal 25, and so on and so forth. While the literal coefficient is a perfect square having an even number exponent, such as x squared. X to the 4th can be written as x squared squared, x to the 6th as x cubed squared, x to the 8th as x cubed squared, x to the 10th as x to the 5th squared, and so on. Now, here are the steps required for factoring a difference of two squares. Number 1. Decide if the two terms have anything in common called the greatest common factor or GCF. Do not forget to include the GCF as part of your final answer. Number 2. Rewrite the original problem as difference of two perfect squares. 3. Write the binomial factors made of perfect square roots plus and minus sign. Let's now have the given problems. Are you ready? Factor each of the following polynomials completely. Number 1, x squared minus 9y squared. Number 2, 16a squared minus 25b squared. Number 3, x cubed minus x to the 5th. Number 4, 64y squared minus 81. Let's answer them now. Problem number 1. Given the equation x squared minus 9y squared can be written as 1 x squared minus 9y squared. The numerical coefficients 1 and 9 are both terms are perfect squares. The literal coefficient both x and y are even powers of 2. Since they are in a difference of 2 squared, let us try to solve. We can rewrite x squared minus 9y squared as the quantity x squared minus the quantity 3y squared. Since both terms are squared, the factors are the sum and difference, which are x plus 3y the quantity x minus 3y. So therefore, the factors of x squared minus 9y squared are x plus 3y and x minus 3y. Problem number 2. Given the equation 16a squared minus 25b squared. First, decide if the two given terms have anything in common. We don't have. As you can see, 16 and 25 are perfect square. A squared and b squared are also perfect squares. So we have the difference of two squares. We rewrite the equation. We have the quantity 4a squared minus the quantity 5b squared. And these are the roots. Therefore, write the binomial factors made of perfect square, plus and minus sign. So we have the quantity 4a plus 5b, the quantity 4a minus 5b. So the factors of the given equation 16a squared minus 25b squared are the quantity 4a plus b times the quantity 4a minus 5b. Problem number 3. Given the equation x cubed minus x to the fifth. Again, decide if the two given terms have anything in common, the greatest common factor. Do you think do we have? Yes, it is x cubed. If we try to solve, x cubed divided by x cubed will give us 1. So we have x cubed, the quantity 1, minus x to the fifth divided by x cubed will give us x squared. So we have x squared. The initial factor of x cubed minus x to the fifth is x cubed, the quantity 1 minus x squared. As you can see, 1 minus x squared is the difference of 2 squared. Again, we have to factor this. Again, we are given 1 minus x squared. We rewrite them as a square. So the quantity 1 squared minus the quantity x squared. Again, this is a difference of 2 squared. The factors are the quantity 1 plus x and the quantity 1 minus x. To complete the factors of x cubed minus x to the fifth, we have to write the common factor x cubed, the quantity 1 plus x and the quantity 1 minus x. Exciting! Am I right? Here is the summary of the type 2 problems. Again, problem number 4 is yours to answer. We have more types of factoring and exercises to follow when Fernandino Teens TV returns. Stay tuned!
Maya po oras kaya kayo, Fernandinos. Ako pala ay Elwin Arl Serrano ng City Tourism Office ng Ciudad San Fernando. Ngayong bulan na ini, pagmasusyantaya ang National Heritage Month na ating temang Victory and Humanity, Upholding Filipino Heritage and Identity. Kambena nini, metong karang aktibidades na ng syudad, atin ning launching ning bayong Heritage Passport. Yung Heritage Passport, apin ning metong karing proyekto ning kaya katamong syudad, yung pamanamuna ng Mayor Edwin D. Santiago. Anong nuka rin makalagelangan ding eganagan ng heritage sites, heritage structures, na akit tamo king kaya katamong heritage district. Makakaya daw din Kenny, ding importansya daw ding mapila na tradisyon, Kenny syudad, kalupa na ng pamangawang parol, ang poing pamangalesa. May awo siyang heritage passport, uling atin kang dapat gawan, anong nukaran puntalan mo lading at tsuking passport, at saka ka mag-selfie. Kay ba't kanta, palto making tourism office, at mamiyalang sticker ka rin ganang apuntulan mong lugar. At timong may ngari ang tutong passport. Balo mi ngeni, panahon na ini, etamo makain bisa lumal, uli na ng COVID-19 pandemic. Kaya naman kimbanwa ngayon agkatan ko la ding bikers tamo, edad 18 hanggang 50, imbis na lumaot kayo po, di na nyo lang dita ka oras di kaya katamong heritage structures, Kenny syudad. Anya naman karing mumunang 50 bikers ang makayari kaya katamong heritage passport, midinan lang premium only San Fernando loot bag. Inggawan nyo mo bakit makapag-register, punta kayo mismo opisina na ng City Tourism, ng munisipyo, at saka kayo magdalang metong valid ID. Kabinan kaya kayong heritage passport, ating makasipit ang instruction nung nano pa ing dapat gawan. Anya naman ka rin hanggang kapadyakin, nanano ko pa, tara na!
Fernandino Teens TV.
You are still watching Fernandino Teens TV. We have already identified the first two types of factoring. Type 1, the common monomial factor, which can be done by getting the greatest common factor. And type 2, the difference of two squares, recognizing a special pattern, which is the sum and difference of two same terms. Let us proceed to the next type of factoring. Type 3, from square binomial of the special product to the perfect square trinomials. Given the illustration, x squared plus 2xy plus y squared is equal to the quantity x plus y squared minus 2xy plus y squared equal to the quantity x minus y squared. Here are the following conditions that must be observed to be considered as a perfect square trinomial. Number 1. Decide if the given three terms have anything in common called the greatest common factor. Do not forget to include the GCF as part of your final answer. 2. The first and the third terms are perfect squares. 3. The second term is plus or minus twice the product of the perfect roots of the first and the third terms. And finally, number 4, if the problem satisfies the given conditions, then the factor is the square of its sum or difference. Now, let's have the exercises. Factor each polynomial completely. 1. Y squared plus 6y plus 9. 2. 9x squared minus 30x plus 25. 3. 4x squared plus 20xy plus 25y squared. 4. 2x squared minus 20x plus 50. Again, be reminded to observe the condition in factoring the perfect square trinomials. Let's have the exercises. Problem number 1. Problem number 1. Given the equation y squared plus 6y plus 9. Again, decide if the given three terms have anything in common. As you can see, we don't have. If you have to observe the first term and the third term, these are perfect square. If we have to rewrite, the quantity y is squared, and we have 3 squared. As you can see, the second term must be twice the product of the roots of the first term and the third term. So we have twice the product of y and 3. So if we have to find the product, 2 times y times 3 will give us 6y. So as you can see, the roots, if we have to twice the product of the root, we have given satisfy 6y. So therefore, as you can see, if the problem satisfies the condition, then the factor is the square of its sum or difference. Since we have the sum there, we are given the factors are y plus 3 and y plus 3. Or we can say it is the quantity y plus 3 squared. Problem number 2. Given the equation 9x squared minus 30x plus 25. Again, decide if the given three terms have anything in common. We don't have. If you look at the first term and the third term, both are perfect square. Even the quantity 3x squared for our 9x squared. We have 5 squared for our 25. Again, in finding our middle term, we have twice the product of the root of the first term and the third term. So 2 times 3x times the quantity 5. So the product is 2 times 3x times 5 will give you 30x. Does it satisfy the middle term? Yes, it satisfies the middle term. Then, it is a perfect square trinomial. Therefore, the factors are 3x minus 5 and the quantity 3x minus 5. Or we can say the quantity 3x minus 5 squared. Problem number 3. Given the equation 4x squared plus 20xy plus 25y squared. Again, decide if the given three terms have anything in common. Obviously, we don't have. If you look at the first term and the third term, these are perfect square. To rewrite, we have 2x squared for our 4x squared. 5y squared for our 25y squared. In looking at our middle term, twice the product of the roots of the two terms. We have 2x multiplied by 5y. And the product is 2 times 2x times 5y will give you 20xy. Does it satisfy the middle term? Yes. Therefore, it is a perfect square trinomials. Given the roots 2x, we will use plus 5y times the quantity 2x plus 5y, or simply 2x plus 5y squared. How do you find the problems, dear students? Excellent! It's nice to hear that. Again, here is the summary of the type 3 problems. Do not forget to answer problem number 4. Let us proceed to type 4. Type 4, from the cube of a binomial to the sum and difference of two cubes. A polynomial in the form of a cube plus b cube is called the sum of two cubes because two cubic terms are being added together. The polynomial in the form of a cube minus b cube is called the difference of two cubes because two cubic terms are being subtracted. Given the equation x cubed plus y cubed equals to the quantity x plus y times the quantity x squared minus xy plus y squared. The second one, x cubed minus y cubed, equal to the quantity x plus y times the quantity x squared plus xy plus y squared. A numerical coefficient or a number is a perfect cube if it is expressed as a product of three equal integers. It means you must be familiar with the perfect cube numbers, such as 1 times 1 times 1 equals 1, 2 times 2 times 2 equals 8, 3 times 3 times 3 equals 27, 4 times 4 times 4 equals 64, 5 times 5 times 5 equals 125, and so on. While the literal coefficient is a perfect cube when it has an exponent of 3 or an exponent divisible by 3, such as x cubed. X to the 6 equal to the x squared cube. X to the 9 equals to x cubed cube. X to the 12 equal to x to the 4th cube. X to the 15 equal to x 5th cube, and so on. Here are the steps to be followed in factoring a sum or difference of cubes. 1. Decide if the two terms have anything in common called the greatest common factor. Do not forget to include the GCF as part of your final answer. Number 2. Rewrite the original problem as a sum or difference of two perfect cubes. 3. Write the binomial factors made of perfect cube root with the same sign with a given problem. Number 4. The trinomial factors is made up of sum of squares of two cube roots, and the middle term is the product of its cube root, and the sign will always be the opposite of the given problem. See the illustration of case number 1 and case number 2. Just remember that the key technique for this is to memorize or remember the patterns involved in the formula. Let's have now the exercises. 1. X cubed plus 8. 2. Y cubed minus 27. 3. 27x cubed plus 64y cubed. 4. 3xy minus 24x to the 4th y. Are you ready? Let's start. Problem number 1. Problem number 1. Given the equation x cubed plus 8. First, decide if we have a common factor. Do we have? Obviously, we don't have common factor. But the first and the last term are both perfect cubes. To rewrite the equation into perfect cubes, we have the quantity x cubed plus the quantity 2 cubed. 2 cubes is equal to 8. Write the binomial made of perfect cube roots. The sum equal, the binomial is, we have to copy the roots, x plus 2. Next, what we have is the trinomial. The trinomial is made up of the sum of square of two cubes, which is x squared plus 2 square minus the product of its cube root. So 2 times x will give us 2x. To simplify, we are given the binomial x plus 2 and the trinomial x squared. It is minus the opposite sign, 2x plus 4. So therefore, the factors of x cubed plus 8 is equal to the quantity x plus 2 times the trinomial x squared minus 2x plus 4. Problem number 2. Given the equation y cubed minus 27. Obviously, we don't have common factor. This is called the difference of two cubes because two cubic terms are being subtracted. If we rewrite this equation into cube, y cube or y cube and 27 as 3 cube. Y and 3 will be our perfect cube roots. To have the factor, the binomial is consists of the difference of the roots of the given term, y minus 3. And the trinomial will be the squared of the 2. So we have y squared plus 3 squared. And again, the opposite sign will be plus because it is minus the product of the two roots. 3y. 3 times y. To simplify, the factors of y cubed minus 27 will be y minus 3 as the binomial, and the trinomial will be y squared plus 3y plus 3 squared, which is 9. Problem number 3. Given the equation 27x cubed plus 64y cubed. Obviously, we don't have common factor. These are perfect cube roots. This is said to be the sum of two cubes because two cubic terms are being added. To rewrite this cube, we have for 27x cubed, we have 3x, then cube for our 27x cubed. 64y cubed will become 4y and then cube. As the says rule, the factors is composed of the binomial, the roots of the sum of the binomial. So we are given 3x plus 4y. That is the given binomial. And the trinomial will compose of the square of the given roots, the sum. So we are given 3x squared plus the third term, the quantity 4y squared. And the middle term is the opposite sign of the given example, that is minus the product of 3x times 4y. To simplify, we are given the binomial 3x plus 4y. The quantity 3 squared is 9, x squared minus 3 times 4 will give you 12xy plus 4 squared is 16y squared. So therefore, the factors of 27x cubed plus 64y cubed is equal the quantity 3x plus 4y times the quantity 9x squared minus 12xy plus 16y squared. Very challenging and exciting, am I right? Very good. Here is the summary of the type 4 problems. Don't forget to answer problem number 4. We will have the last type of factoring when Fernandino Teens TV returns, so stay with us.
Hindi lamang sa larangan ng pangkabuhayan apektado ang maraming pamilyang Pilipino, kundi maging sa larangan ng pagkatuto ng bawat batang Pilipino. Inilunsad ng siyudad ng San Fernando ang programang Nurturing Environment and System for Thriving or NEST, isang education community pantry na naglalayon para sa isang malawakang pagtulong, pagantabay at paggabay na ang focus ay ang makapagbigay ng tulong at suporta sa ating mga mag-aaral sa pamamagitan ng pagbibigay ng educational needs gaya na lamang ng school supplies, tutorial sessions, study tips, at iba pang mga pamamaraan na mas lalong makatutulong sa pag-angat ng ating edukasyon. Dahil hindi hadlang ang pandemya sa magandang kinabukasang naghihintay sa ating mga mag-aaral. Sino-sino nga ba ang mga kalahok sa programang ito? Sa pagtutulungan ng ating school administrators, guro, magulang, at iba pang mga miyembro ng ating komunidad gaya ng barangay officials at sangguniang kabataan ay siguradong magiging mas matagumpay ang programang ito. Paano nga ba ang magiging proseso ng naturang programa? Una, magkakaroon tayo ng isang Facebook group, ang Pampanga High School NEST Education Community Pantry na pangungunahan ng Educational Pantry Coordinator. Ang mga magulang, tagapangalaga at mga guro ay ia-add ng ating Educational Pantry members sa Facebook group na ito. Sa page na ito maaaring i-post ng mga magulang at tagapangalaga o sino mang miyembro ng Educational Pantry ang kanilang mga kahilingan o requests. Kailangan ding ilagay ang pangalan ng mag-aaral, grade, at section para sa mas agarang aksyon. Oo nga pala, hindi lang requests ang pwedeng i-post. Pwede ring mag-post ang mga nais magbigay ng tulong o mga gustong mag-donate. Sabi nga nila, sharing is caring. Tandaan na ang Facebook group na ito ay pribado at posts na may kaugnayan lamang sa page na ito ang maaaprobahan. Mayroon din palang Google Form na ipamamahagi kung saan maaari nating isumite ang ating requests o kahilingan. Paano naman ang mga walang internet access sa bahay? Huwag mangamba dahil merong mga nakalaang drop boxes ang ating paaralan na kung saan maaaring ihulog ng mga magulang at tagapangalaga ang kanilang requests. Sa mga nais namang mag-donate ng school supplies, maaaring ilagay ang mga ito sa tabi ng drop boxes. Maaari ring mag-donate ng mga kagamitan o cash donation kaakibat ang pagsusumite ng deed of donation form. Pangalawa, mahalaga ang ugnayan ng mga guro at ng mga magulang o tagapangalaga sa programang ito. Gamit ang video calls o chats ay ipahahayag ng mga guro ang adhikain ng programang ito sa mga magulang o tagapangalaga. Maaari ring gawin ang orientation na ito ng face-to-face kasabay ng schedule ng kuhanan ng mga module. Gaya ng nabanggit, hindi lamang mga bagay ang maaaring i-donate. Pwede ring mag-conduct ng tutorial session, study tips, at iba pang mga kagamitan sa pagkatuto gaya ng mga aklat o kaya ay gadgets. Ikatlo, ang requested needs ng ating mga magulang o tagapangalaga ay ililista ng ating NEST focal person. Ang mga coordinator naman ang mag-aayos ng mga ito. Ang advisors ng ating mga mag-aaral, guidance counselor, at iba pang mga guro ay ipaaalam sa ating mga magulang at tagapangalaga ang petsa at oras ng pamimigay ng requested needs na gaganapin sa paaralan. Sabi nga nila, it takes a village to raise a child. Kaya naman aktibo at iba yung pakikilahok ang inaasahan sa pagsasanib puwersa ng paaralan at barangay na siyang tutukoy sa pangangailangan ng bawat Fernandinong mag-aaral at kikilos upang matugunan ito sa tulong at suporta rin ng mga miyembro ng komunidad. Isang malawakang komunidad para sa isang produktibong educational community pantry ay tiyak na lilikha ng iba yung pagkilos upang maging mas magaan at madali ang pagkatuto ng bawat kabataang Fernandino. Kaya naman tandaan, magbigay ayon sa kakayahan, kumuha ayon sa pangangailangan.
Fernandino Teens TV.
You are still watching Fernandino Teens TV. We have already identified the 4 types of factoring. Type 1, the common monomial factor. Type 2, the difference of 2 squares. Type 3, the perfect squared trinomials. And type 4, sum and difference of 2 cubes. Are you ready for the next type? Type 5, trinomial with distinct factors. Quantity AC x squared plus quantity AD plus BC xy plus quantity VD y squared is equal to the quantity AX plus BY times the quantity CX plus DY. Others said that this type of factoring is a trial and error method, familiarizing with the FOIL method as we discussed before. But let me have to present to you the other way, or maybe the easiest way of finding the factors. Here are the steps to be followed. First, equate the given trinomials into 0. Second, calculate the product of the numerical coefficient of the first and the last terms. Third, identify the possible factors of the given product that could satisfy the sum or difference of the middle term. And lastly, substitute factors pairs into 2 binomials. Let's have the exercises to really understand the process. Number 1, x squared plus 5x plus 6. Number 2, x squared minus 7x plus 12. Number 3, 2x squared minus 7x minus 4. Number 4, 2ax squared minus 24ax plus 72a for your part. Problem number 1. Given the equation x squared plus 5x plus 6. Obviously, we don't have common factor here. First step, equate the problem to 0. So we have x squared plus 5x plus 6 is equal to 0. Get the product of the numerical coefficient of the first term, which is 1, and the last term, which is 6. So we have 1 times 6 will give us 6. Then, think of a factor of 6 that could possibly to get the sum of the middle term, which is 5. And the factors are 2 and 3, whose sum is 5. Then substitute the factor pairs into binomial. So we have 1 x squared plus, instead of 5x, we will write 2x plus 3x plus 6. Then, after that, we have to simplify again. Combined term, we have x squared plus 2x, that quantity, plus the quantity 3x plus 6. Finding the common factor, we have x squared plus 2x. The common factor is x. Very good. So we have x squared divided by x. We have x plus 2x divided by x will give us 2 plus the common factor of 3x plus 6 is 3. Very good. So again, quantity 3x divided by 3 will give us x plus 6 divided by 3 will give us 2. So we have x, the quantity x plus 2, plus 3, the quantity x plus 2. As you can see, the common factor here is, we have the common factor now. What's the common factor? We have x plus 2. Then we have x plus 3 times x plus 3. So therefore, the factors of x squared plus 5x plus 6 is equal to the product of the binomial x plus 2 and x plus 3. Problem number 2. Given the equation x squared minus 7x plus 12. We don't have common factor here. First step, equate the problem to 0. So we are given x squared minus 7x plus 12 equal to 0. Get the product of the numerical coefficient of the first term, which is 1, and the third term, which is 12. So we have 1 times 12, and the product is 12. Then, think of a factor of 12 that could possibly to get the sum of the middle term, which is negative 7. So we have negative 3 and negative 4. Then, substitute the factor pairs into two binomials. So we have equal x squared minus, we will write negative 3 instead of negative 7x. So we have negative 3x minus 4x plus 12. Combining terms, we have x squared minus 3x minus the quantity 4x, we have minus 12. Why is it minus 12? Because negative times negative will give us positive. Think of a common factor. We have x squared minus 3x. We have x. Very good. Quantity x squared divided by x will give us x minus 3x divided by x is 3 minus the common factor of 4x and negative 12. We have, very good, we have 4. The quantity 4x divided by 4 will give us x. Negative 12 divided by 4 will give us what? It is negative 3. Very good. So, the common factor x minus 3 and x minus 4. So, we have x minus 3 common factor, and then we have the quantity x minus 4. So therefore, the factors of x squared minus 7x plus 12 is equal to quantity x minus 3 and x minus 4. you can check your answer using the FOIL method. Problem number 3. Given the equation 2x squared minus 7x minus 4. Obviously, we don't have common factor. So first step, equate the given equation into 0. So we are given 2x squared minus 7x minus 4 is equal to 0. Find the product of the numerical coefficient of the first term, which is 2, and the second term, negative 4, equal to negative 8. Then think of a factor of negative 8 that could possibly get the sum of the middle term, negative 7. So we have positive 1 and negative 8. Because if we have to find the sum of 1 and negative 8, we have negative 7. Then, substitute the factor pairs into two binomial. So we have 2x squared. Instead of writing negative 7x, we will use the factor, that is 1, plus 1x or x, minus 8x minus 4 is equal to 0. Combining terms, we have 2x squared plus x minus the quantity 8x plus or minus. Yes, it is plus because that is minus. Positive times negative will give us negative plus 4. 2x squared plus x, the common factor is x. We have the quantity 2x. X divided by x plus 1 minus common factor of 8x and 4. Very good. We have 4. 8x divided by 4, 2x plus 4 divided by 4 will give us 1. So the common factor of the 2 is 2x plus 1, quantity x minus 4. So therefore, the factors of 2x squared minus 7x minus 4 is the quantity 2x plus 1 and x minus 4. Were you able to follow? Great! Here is the summary of type 5 factoring, trinomials with distinct factors. Let us have our recap for this factoring and be ready to have your answers in all types. Again, we have type 1, the greatest common factor, type 2, difference of two squares, type 3, perfect square trinomials, type 4, sum and difference of two cubes, type 5, trinomial with distinct factors. Now, are you ready to check your answers? Let me show it to you. Do you have the same answers with me? Excellent. As you can see, factoring is a very challenging skill in mathematics. Also, a useful skill in real life. Related application may include understanding time and making calculation in our everyday works in life, dividing equal parts, observing and comparing prices of commodities, and even making money in exchanging currencies and others. Factoring is often a key skill for solving problems in which you can need to find the value for solution about anything. Dear students, in mathematics, just analyze the problem carefully and understand every mistake that we have. You have to do more practice. I hope that you enjoyed and learned something new today. This is the reference that I use in this presentation. Once again, This is your teacher, lecturer, Sir Dong. Thank you for listening and always stay safe. Godspeed.
O ano, Nan? Naging malinaw na ba sa'yo ngayon kung paano i-compute ang special factor?
Oo, mabuti na lang at naipakita lahat ni Sir ang types of factoring.
Masasagot mo na ngayon ang activity mo. Kaya naman, maraming salamat, sir!
Isa na namang makabulahang talakayan ng ating natunghayan Fernandino Teens.
Magkita-kita tayong muli sa susunod na episode ng
Fernandino
TV, na kung saan ang kabataang Fernandino ay angat sa ating talino.
Bagong umaga, yakapin mo ang bagong pag-asa. Simulan mong abutin ang iyong pangarap na magbibigay dangal sa iyong bukas. Ang suliranin, hindi laging nandyan, dapat mong harapin. Kami iyong kasama sa bawat takin, magkaakbay nating lulutasin. Dito sa Fernandino Teens TV, ang boses mo ay mahalaga. Dito sa Fernandino Teens TV, ikaw lagi ang bida. Ang mga aral ay ginintuang atin ng bawat guro na siyang gagabay sa iyong pagkamulat. Naway umukit ito sa iyong isip.